Okay, so our first question on our review sheet is wanting us to make a Venn diagram. So we're talking about 80 students are asked whether they like sharks, crocodiles, or hippos. So they want us to fill in everything. So they give us a bunch of information. So the first thing I noticed is that I have 15 students that likes all three. So that would be like the middle of my Venn diagram. So it's the intersection of all three events. So the 15 is going to go in the middle. I guess like down here, they want us to put it in the different blanks. So 1A is this question 1, spot A is 15. And this is kind of how it'll be set up like on your quiz when you're entering it in Canvas. So that is just to help you like get used to that. All right. So the next thing they give us is that 14 students like sharks and crocodiles, but do not like hippos. So that's going to be between the sharks and the crocodiles, but it's not included in the kids that are students that like hippos. So it would be only be because this part A like includes hippos, it includes the hippo circle. So it's only going to be in the B. So it's only going to be 14 right here. So 14, that's going to be B. Alrighty. So our next piece of information is that 23 students like crocodiles and hippos. So that's going to be my between crocodiles and hippos, my and. So we're talking about the 23 right here. So that means this part right here between the crocodiles and the hippos, that intersection, that whole thing should be equal to 23. So, because we are including the A part. So we need to figure out, that's going to help us figure out what C is. So we would do 23 minus the 15 to get what C is. So that would be 8. So I would have 8 for C. Because we want, like I said, we want this whole thing to be equal to 23. So we have to subtract the 15 from the 23. So C would be 8. All right, next thing they give us 21 students like sharks and hippos. So that's going to be the intersection between sharks and hippos. So right here. So that means that this part needs to be equal to 21. So to figure out what D is, we're going to do 21 minus the 15 that's already in there. So D would be 6. So I should have a 6 right there. All right, next thing they give us is 44 students like crocodiles. So that means that the whole crocodile circle needs to be equal to 44. So in total, I have 44 students that like crocodiles. So if we want to figure out who just likes crocodiles, so my F in this case, we need to take the 44 and subtract the 14. We need to subtract the 15, and we also need to subtract the 8. So 44 minus 14, just my calculator. 44 minus 14 minus 15 minus 8, that gives me 7. So F, so I only have 7 kids that just like crocodiles and none of the other animals. And then the last thing they give us is that 12 students only like sharks. So it's just this part right here, the only, so I have a 12 for sharks. So it's only the sharks, not including anything else. All right. So then we need to figure out what G is. So the only hippos. So it says in the original problem, it says that 80 students like at least one of the animals. So all of my students like at least one. So that means like sometimes we saw that in our sample space, we had like a few out here. But if they're telling us that all of them like at least one, that means we don't have any on the outside. They're all in the Venn diagram. And we have in total 80 students. So to figure out how many hippos we have, we're going to take our 80 So we're trying to find hippos right now, just the hippos. And we need to subtract everything that's already in the Venn diagram. So the 12. We need to subtract the 14. We need to subtract the 7. We need to subtract the 6. We need to subtract the 15 and the 8. So we do all of that, and that's going to give us just what's left over for the hippos. So 80 minus 12 minus 14 minus 7 minus 6 minus 15 minus 8. That leaves me with 18. So I have 18 kids or students that like just the hippos. So they'll have everything, and you can recheck yourself. You could add all the numbers up inside, and that should be equal to 80 students. All right. So then they have us answer a few questions. So 2A. So, and they said event A is sharks, event B is crocodiles, and then C is hippos. So if I want to find how many students are in not A, so that don't like sharks, because A is sharks. They don't like sharks. So if we want to do not A, we can do like the entire thing minus what is in A. So we can take our total amount, 80, and subtract what is in A, and that will give us what's not in A. So my total amount of kids that like sharks, we would add up the what's in the shark circle. So 12, 6, 15 plus 14. So my total amount for sharks would be the 12 plus the 6 plus the 15 plus the 14. This is my A. What's in sharks? So that is 12 plus 6 plus 15 plus 14. So 47. Let me subtract those two numbers. So 80 minus 47 would be 33. So I have 33 people or students that are not in A. All right, so then we want part B says how many students are in C or not B. So how many are in C? So how many, let's think about this. So C is hippos. So how many like hippos? So like hippos. Or don't like crocodiles. So if I think about this, I want my whole entirety circle of hippos, because we want all the kids, all the students that like hippos. So we want all the hippos and then don't like crocodiles as well. So we can also include these people who like the sharks. So we want everything in hippos. So we want 18 plus 8 plus 15 plus 6 plus the 12 that are in the only sharks. And we can include, so I'm also including price 15 right here. I'm also including this part right here, even though it's including the crocodiles, because this is an or probability. So with the and probabilities, it has to happen at the same time, but since this is an or, it can happen one or the other. So we can include that part. So if we add all this together, so 18 plus 8 plus 15 plus 6 plus 12 will be 59. All right, how many other students are in the subset not A and B and C? So we want, we can do 80 minus what is in A and B and C to figure out what is not in A and B and C. So this part right here, A and B and C, that's the intersection of all three events. So that's the middle part where they all come together. So the 15. So we want to do 80 minus 15. So we can get what's not in that. So that would be 65 students. All right, and then our last one, D, says how many students are in the subset A and B? So that's where, so A and B is sharks and crocodiles. So we're gonna look where they cross. So they cross right here. This is the intersection of A and B. So 14 and 15. So we want 14 plus 15, which would be 29. Okay, so number 3 says Melissa collects data on her college graduating class. She finds out that out of her classmates, 60% are brunette, 20% are blue eyes, and 5% are brunette that have blue eyes. What's the probability that Melissa's classmates will be a brunette or have blue eyes? So this is an or probability. So this means we're going to use the addition rule. So addition rule, remember, it's the probability of A or B. This is the general formula. So it's a probability of the first event plus the probability of the second event minus the probability of the event's intersection. That's the general formula for our addition rule. All right, so for this one, we're finding an or probability. So we're finding brunette or have blue eyes. So I'm going to say this is brunette. I'm going to say BR. And then blue eyes, I'm going to say BE. So it will be the probability of a brunette plus the probability of blue eyes minus the probability of brunette and blue eyes. So they give it to us. They give us percentages, and we always want to write our probability as a decimal, not as percent. So they tell us in the problem that 60% of them are brunettes. So that's going to be 0.6 as a decimal. Then the probability of them having blue eyes is 20%. That's our next information. So that would be 0.2. Or I guess if you want to write it, 0.2. And then they say 5% are brunette that have blue eyes. So they're brunette and also have blue eyes at the same time. So that's the intersection. So we're going to minus 5% would be 0.5. So we add 0.6 plus 0.2 minus 0.05. So that will give us 0.75 for our answer. Okay, number 4. Karen takes her group of 3rd grade students out for ice cream. There's a total of 30 students. 13 of the students like chocolate ice cream. 12 of the students like strawberry ice cream, and 5 students like vanilla ice cream. When asked their favorites, when asked which 2 ice creams are their favorite, 8 students said they like both chocolate and strawberry. Out of the 30 students, what is the probability of a student liking only chocolate or strawberry? So this is another or probability. So we're going to use the addition rule again. So we want chocolate or strawberry. So we want probability of, all right, closer, probability of chocolate or strawberry. So we do the probability of chocolate plus the probability of strawberry minus the probability that they like both at the same time, chocolate and strawberry. So let's see. So probability of chocolate, there's 30 students. Let's see. 13 of the students like chocolate ice cream. So our probability for chocolate is 13 out of the 30. And then we're adding probability of strawberry. So 12 of the students like strawberry ice cream. So 12 out of the 30 for our strawberry probability. And then they also give us 5 students like vanilla ice cream, which we don't really care about in this situation because that's the question's not asking us to find anything related to vanilla ice cream. So that piece of information is kind of just like a distractor piece. But they also say that when they like 2 ice creams, 8 students say they like both chocolate and strawberry. So that's our intersection. So minus the 8 out of the 30. All right, so we already have a common denominator for all these fractions, so we just add the tops. So 13 plus 12 minus 8 will give me 17. And we always write our probability as a decimal, so 17 divided by 30. So it's about 0.57 for that one. All right, so then we get into, we have a two-way frequency table. So this table is showing us the results of a survey about what the engineers said their favorite subject was in middle school. So the first one they ask, ooh, all these are A. Let me change these. B, C, D, E. Okay, so the first one asks the probability of, so part A, probability of science. So we just want in total, how many people like science. So the total amount of science, I'm looking at my science column, would be 262. So it'd be 262 over the total amount of people in the survey. So the 516. And if we divide that, we would get 0.51. All right, next one is math and electrical. So we want to look at our math column and then our electrical row. So where they cross, so the 85. And then we want the probability out of the total amount of people, so 516. So that would be 0.16 for that one. All right, the next question is another and, so chemical and science. So we want to look our chemical row and then our science column where they cross. So they cross at 91. So 91 people like chemical and science. So we want 91 over the total amount of people, 516. 91 divided by 516. So 0.18. All right, so the next two are or probabilities. So we're going to use the addition rule for these. So the next one says probability of mechanical or math. So that means we need to do probability of mechanical plus probability of math minus probability that they like mechanical and math. All right, so probability. So probability of mechanical, we just want like the total amount of people that do mechanical. So look at 170 over the 516. And then probability of math. So we want the total amount of people that like math. So going to our math column. So it looks like 254 out of our total amount of people in the survey, 516. And then we subtract the intersection of the math and mechanical. So that would be this 89 where they cross. So 89 over 516. So we already have a common denominator, so let's just add everything in the top. So 170 plus 254 minus the 89 will give me 335 out of 516. Divide that, we get 0.65. All All right, and then the last part for this question, part E, another or probability. So probability of electrical or science. So we want to do probability of electrical plus the probability of science minus the probability that we do electrical and science at the same time. So probability of electrical. So we're going to look at our electrical row. So we want the total, so the 175. So 175 over 516. And then probability of science, we want the total for that. So total amount of people that like science are 262 over a total amount of people, 516. And then we subtract their intersection, so where they cross, so the 90. So we do 90 over 516. And so add this together, 175 plus 262 minus the 90, 175 would be 347 over 516. Divide that, so that'd be 0.67. Okay. All right, so our next question, another table. So it says 50 students in the 8th grade class were asked what kind of ice cream they like, vanilla or chocolate, and then what kind of toppings they like. So they want us to finish the table first, and then we're gonna do figure out our probabilities. So to finish this table, let's start here, sprinkles and vanilla. So this total for this row needs to be 30. And I already have 8 and 13. So what I can do is do 30 minus 8 minus 13, and I get 9. So 9 plus 8 plus 13, that would equal 30. So we're good. All right. Oops, just erased my 9. So then we can find the total right here for sprinkles. We can just add 9 plus 7, get 16. We could add this row, 8 plus 9, so total 17 kids like M&Ms. And then we also need to get the total for chocolate, so the chocolate row. So we need to add the 7 plus the 9 plus the 4. So that would be 20. All right, and then we need to figure out the total amount of kids, like in the bottom right. So we do 30 plus 20, which would give us 50. And we can also make sure that 16 plus 17 plus 17 equals 50, which it does. So we're good. So the total amount of kids they surveyed, 50, which they told us in the problem. Okay, part A, determine the probability a student likes no toppings. So nothing, so we want to look at the nothing column. So we want that they don't like any toppings at all. So the total amount of kids that don't like any toppings are 17 out of the 50 kids in the survey. So 17 divided by 50 is 0.34. All right, so then we want kids, for part B, we want probability of a student liking vanilla ice cream and not M&Ms. So we want to look, who likes vanilla? So how many kids like vanilla? 9. And at the same time, we don't want them to like M&Ms. Okay, wait, so let's think about this. So we want vanilla. So we're looking at our vanilla column. We don't care about the other ice creams, just the vanilla. At the same time, we don't want them to like M&Ms. So we want the kids that like the sprinkles, and we want the kids that like nothing. So we don't want the 8 kids that like the M&Ms. So we want the 9 and the 13 kids that like vanilla with sprinkles and vanilla with nothing out of the 50 kids in total. So again, we don't want to include any kids that like M&Ms, so we don't include the 8. So that would be 22 over 50, which is 0.44. All right, last question for this table. Determine the probability of a student liking sprinkles or chocolate ice cream. So another or probability. So this is where we use our addition rule. So probability of sprinkles or chocolate. So we want probability of sprinkles plus probability of chocolate minus probability of sprinkles and chocolate. So we're using our addition rule. Okay, so probability a kid likes sprinkles. So let's look. We want the total amount of kids that like sprinkles. So the 16. So 16 out of the 50 kids. Then we want probability of chocolate. So look at your chocolate row. We want total amount of kids that like chocolate. So 20. So 20 out of 50. And then we subtract their intersection. So where chocolate and sprinkles cross. So the 7. So 7 out of the 50. So we add everything up. 16 plus 20 minus 7. So 29 out of 50. So that would give me 0.58. All right, and then that's it. I forgot to take this stuff off. We have not talked about this stuff down here, so don't worry about that stuff.